Welcome back to my YouTube channel. In this video, guys, we'll be dealing with we'll see the rankings formula. Okay, before we go to that, I want to rectify my mistake. Remember, we've discussed about how we calculate the weight when you have given a density and the diameter. Then we say per. They say that meant the weight of the shaft per meter. It's just a little mistake. Remember, it's supposed not be in Newton only, must be Newton per meter. That only these guys that I wanted to rectify. Write Newton per meter because you've taken that to be what per meter. So just write this Newton per meter. Only that, nothing more. Okay. So what I want us to check, guys, let us look at what we call Rankine formula for bending and twisting. All right. So, and then the term you see there is denoted by this region is denoted by ME, is called the equivalent bending moment. Now we'll look at the equivalent bending moment. Remember, we've looked at the equivalent torque. We did equivalent twisting moment. Right now, we'll look at equivalent bending moment. Right, this is denoted by ME. All right, and may be described as a fictitious bending moment that will induce the same tensile principal stress in the shaft under the actual combined bending moment and twisting under the actual. They're talking about the actual. So, how do we determine this Rankine formula? This Rankine formula ME, or there, that is ME like this, is simply given by 1 over 2. We have there our, let me do like this. We have there our maximum bending moment plus the actual, guys, you see there. Let me not waste time by writing what, but as you can see, it's 1 over 2. It's ME, it's equals to 1 over 2 maximum bending moment to square root of m squared maximum bending moment squared plus this is measured in Newton, or is given by this formula, or is given by that. This one, the familiar one that we'll use the most is this one, ME. Most of the time we'll use this 1 over 2, but it's m. Remember that m is a maximum bending moment plus our if plus te, check that into then bracket like this, measured in Newton meter, our equivalent twisting moment plus our equivalent twisting moment, or use this. Why say te, guys? Why we say te is because, you know, guys, this is equals to te. Remember, we have learned about that. Remember, te is equal to the square root of m squared plus m squared. So simply te, it's one and the same thing, guys. This actual and this and that, it's one and the same thing. So this is measured in Newton meter. This we call this. Now you see we have 1 over 2 into m plus equivalent twisting moment. This we call this the Rankine's formula. That is our Rankine's formula, whereby we call this is called equivalent bending moment. It's also called equivalent bending moment. As you can see, it's called equivalent bending moment. It's measured in Newton per meter. It's given there. Our equivalent bending moment. Then this maximum torque. So the another formula mainly used for brittle material, because this will tend to fail. Another for shaft, here is a formula again. We have ME. This can be calculated by ME. It's equals to that pi there. You've given that pi d raised to the power of 3. But check, this is a principal stress multiplied by principal. This is a principal, guys. Principal stress divide by 32. Guys, this is a principal stress limit. Principal. This is a principal stress. Then here we have our diameter 32. Here is it is. Oh, sorry about that. There is no diameter. Remember, this is for solid shaft. Hey, what I'm doing there. What I am doing is non-seashell. All right. Divide by 32 like this. This is the principal, as you can see, is pi d cubed multiplied by principal stress over 32 for what? For solid shafts, guys. Then for hollow shaft will be pi into d raised to the power 4 minus d raised to the power of what? Of 4 into multiplied by principal stress over 32 multiplied by diameter. As you can see, guys, there. Hopefully you see there is pi like that, d raised to the power 4 minus d raised to the power 4 multiplied by principal stress. This is the principal, I'll just say period, divided by 32 the d, guys. As you can see, that is 32d, guys. This is what is it is, guys. So this thing, guys, simply just is obviously is equivalent bending moment is measured in Newton meter, as you can see that. So guys, how can we put this into work? Let us check how can we apply this formula. We are given now here the bending and twisting of the solid. Okay, example that they say a flywheel, a shaft with 1 meter length is supported by bearings is situated at each end of the shaft. All right, it's like this, guys. Remember, bearings act as support always. There, this is our length here of the shaft. This shaft here is what? Is 1 meter. That is a shaft. All right. So the shaft carries a flywheel with a mass of that in the center. At the center of that mass, flywheels here is 1000 kgs. There, as you can see, there is 1000 kgs, that of the flywheel, right? But you can just convert that to pin. Let it be force. Remember, must be force. So be 1000 multiplied by 9,81. 1000 multiplied by 9,81 will be 98110 Newton. So that is what we have there. We know that is what we'll be having then. That load that is applying, that point load of the flywheel will be 98110 Newton there. All right, that is what we have there. It's acting downwards. Remember that it's in the middle. It's acting that it's in the middle, guys. It's in the middle. This is a simply supported beam. All right, so far what else? The shaft transmit the power. We have given us the power of 110 kilowatts. We've given kilowatts there. Then this the speed there is 800 rests per minute, and we've given that. Okay, so as you can see, they say stress cannot be more than but they say its shear stress cannot be more than 80 megapascal when the maximum torque exceed the mean torque by 20%. Calculate. Okay, let's check number 1, guys. Number 1 says let us calculate what there. Number 1 want us to determine the diameter of the shaft. Let us determine the diameter of the shaft. The diameter of the shaft. How can you go about this? All right, we want the diameter of the shaft. Okay, this will be the long process, guys. By the way, nevertheless, we'll see how we go about this. Okay guys, we're given the power is given by 2 pi n t, because, and divide by 60 since we have given this in rest per minute. Remember, this will be t what mean, is t mean, that one, make no mistake about that. Then we make t mean the subject of the formula, will be p multiplied by 60 divided by 2 pi n, like this. Then let us substitute there. Power is what? 110 times 10 to the power of 6 multiplied by 60 divided by 2 pi, n is 800. Then what will be our t mean? T mean will be what will be t mean? Will be 1313,028 Newton meter. That is our t mean. But now we know that the maximum torque, guys, the maximum torque T max now supposed to be equals to T mean. We know this formula, we've discussed about it, from N1 plus overload, percentage overload. We know that the percentage overload, divide by 100 only here. All right, so you know how we got T mean is 13.3028 into 1 plus the percentage there we have given to be what? They say the maximum exceed T mean torque by 20%. If given, you write that as it is, guys. We have 20%, 20 over what? We have this 100 there. And then we punch that. As you punch that, our T max there. Now our T max maximum torque now will be equals to 157.634 Newton meter. As we know, this is Newton meter. That is our maximum torque. We have the maximum torque. Sorry about this, guys. I have some flu. Remember, now is simply what will be our maximum bending moment. Let's calculate maximum bending moment. All these steps, you know why we do. I know why I'm doing this. For all these steps, the aim is to find TE, but we have to pass through all these steps. Okay, by the way, we've given our beam. We know that the maximum bending moment, we've given a simply supported beam will be W multiplied by the length. I've discussed about this. Divide by what? By 4. I've discussed about these guys here. I've shown you. Go watch the video where I'm discussing about that. If you have not watched that video, please check it. So will be that. Then our weight there is 910 of that flywheel, isn't it? The length is 1 divided by 4. What will be our maximum bending moment? If you punch that, will be 2452,5 this Newton meter. And then remember, this is a maximum bending moment. We've discussed about that. We know that, guys, that is a maximum bending moment. All right, we've been talking about that. So we've been discussing about that a lot. So now, since we know our things here, we know that TE, by the way, it's equal to the square root of m squared, which is maximum bending moment plus maximum torque. It's in it. So we have this, we've just calculated now, which is 245. We just got it here. I don't remember it, but I remember it's 24 here, 245 2,5 squared plus the maximum torque there, it was 1575.634. Okay, okay, 1575.634, right, squared, all this squared, then this will be equals to what? 22915,026, obviously is in Newton meter. That is our TE, isn't it? So, but we know TE, guys, TE by its own, we want the diameter. TE by its own, we know this is pi, isn't it? Pi d raised to the power of 3 multiplied by what? By the shear stress divided by what, guys? By 16. So I want the diameter, make the diameter the subject, I'll multiply that, then I divide by this, then I take the cube root. If I make diameter the subject of the formula, you multiply TE, multiply by 16, divide by these twos. Right, are you with me there? Pi, you multiply by what? By shear stress. Then you take the square root after the cube root. Then if you take the cubed root, you'll have this. So you can simply straightforward and calculate and substitute what we have there. What d will be equals to cubed root of that. TE is there, we have there 2915026 times 16, like that, divide by pi. Shear stress there, if I still remember, they said must be more than what, 8 megapascal times 10 to the power 6. Should have been given this. Then our diameter, remember this is a solid shaft, it's a solid shaft, it's not a hollow shaft. So diameter, guys, will be 5 let me check. Will be 0,057 yeah, 0.3839, like that, meter. Then round this to 3 decimal places. Let me not write it, but you can round this to decimal places. If you round this to decimal places, okay, just let us multiply all of this by 1000. I want to see what can I have. If I multiply this by 1000, I will have, this will be 9, so will be 57, I will simply have here 57,0339 millimeter, and exact on my calculator. Then this is what we have our diameter done with that. So question 2 says determine the principal stress induced under the maximum torque condition. Okay, right, under this maximum torque condition, we know, guys, to calculate the principal stress. This principal stress will get the principals under the principal stress will be under this, under equivalent bending moment. Under equivalent bending moment, we know equivalent bending moment, it's 1/2 into maximum bending moment plus equivalent twisting moment, like this. Right. Want this. Then we have now 1/2 maximum bending moment is 2 4. The one that we've just calculated on the top is 2 4 5 2.5, isn't it, plus TE, the one we did calculate there on the top, the one here, that of 215,03, yeah, that one of 2915,026, like this. Then punch this there, you'll have this should be equals to 2683,763. This is Newton meter. Now we want the principal, guys. Under this condition, the principal stress by its own, again, guys, is given by what? Yeah, principal stress by its own, guys, is given by what? We said when you are given a solid shaft, it will be pi d cubed multiplied by the principal stress. This is the principal. I'll just say multiply by principal stress. You must know that it's a principal. All right. This is the principal stress, guys. Multiply by that principal stress, divide by 32. So we can find that. I make that. So make that stress, our principal stress, the subject. I will multiply, but that side will be ME multiplied by 32 divided by this whole thing, then pi multiplied by d cubed. Then we substitute there. ME is the one is 2683,763. Then multiply by 32, divide this by pi. Our diameter is the one that we just got there. This number here, 57,039 millimeter, divided by that. Oh, it will be long. Let me just use, guys, I will use 0,057, like to 3 decimal place, then say cubed. Then what will be our principal stress? Punching this, now principal stress, what will be the principal stress here? Therefore, guys, ladies and gents, principal stress, if you have punched this, we'll get this to be 147,306 megapascal. So this is what we have, guys. This is what we have. Thank you, guys, for watching. By the way, this is what we have. This is what we have, guys. This is what we have. This is what we have. Thank you for watching, and may you kindly subscribe to my YouTube channel if you have not subscribed. And then if it is your first time watching my video, may you please subscribe. May you please subscribe to my YouTube channel, and click the notification button so that you'll be notified whenever I post a new video. All the best, guys.